Welcome. Today we are working on 3B, which is graphing linear equations. Our content objective is students will be able to graph linear equations. Our language objective is students will be able to discuss various methods of graphing linear equations. And why am I learning this? Well, it's important for many topics next year, okay? So, first things first, we're going to go over some background knowledge from our previous lesson of how we graphed y equals 3x plus 3. All we did was plug input values for x, substitute them in to see what y equals. In this case, when we substitute 0, we got 3. When we substitute 1, we got 6, etc. And this is our graph. Notice, you'll notice in your homework you're going to have to scale your graphs. So in this case, the x's are scaled by 1s and the y's were also able to be scaled by 1s as well. You're going to graph your ordered pairs. Make sure your line is drawn through your graph. And there you have it. Here our unit rate is going to be represented that for every 3 y's, it's moved over 1x. Okay, again, for every 3y, it's moved over 1x. So here, my unit rate would be 3y for each x. Initial value, where did this graph start? It started right here when x was 0, y was 3. Okay, that could be seen on the graph or that could be seen on the table that you used. So both ways will give you the same answer. Here, also background knowledge from yesterday's lesson. You inputted your values for x, you figured out what y equals, and then you scaled your graphs and plotted your points. Notice this one is negative because our unit rate is negative. So here, our unit rate, let's be a little bit more specific by looking at our graph. It's going down 2y and over 1x. Okay, so it's going down 2y over 1x. So here, my unit rate is 2y for each x. My initial value would be here. You can see it in the table as when x equals 0, y equals 14. Or you can see right here on the graph that when x is 0, y is 15. So that's what we would write there. So now let's move on to our very first example. Here, same idea. We're given an equation. We're going to go ahead and substitute values in for x. So here, the table's already given to us. We're going to be using 0, 1, 2, 3, and 4. So first things first, what I'm going to do is go ahead and write my equation to kind of show how I would plug in my values in for x. This is how I normally would show that. So here, if x equals 0, I'm going to go ahead and put a 0 in for x. What is y? Well, y equals 2 times 0, which is 0 plus 1, so y would equal 1. Now, I'm going to go ahead and repeat this process. Well, what if x equals 1? I'm going to go ahead and put a 1 here for x. Y equals 2 times 1, which is 2, plus 1, which is 3, so y equals 3. Now, continuing on, what if x equals 2? So I'm going to put a 2 here. Y equals 2 times 2 plus 1, so 2 times 2 is 4, plus 1 is 5, so y equals 5 when x is 2. Keep going. What if x equals 3? I'm going to go ahead and write a 3 here. Here, y equals 2 times 3, which is 6, plus 1, which is 7, so I'm going to put y equals 7 when x is 3. And last but not least, what happens if x equals 4? So y equals 2 times 4, which is 8, plus 1, which is 9. So when x equals 4, y equals 9. So now that I have these ordered pairs, I want you to kind of take a look because I want you to notice something. Okay? First of all, I want you to realize as my y values are increasing by 2, my x values are increasing by 1. Here, my y values are increasing by 2, my x values are increasing by 1. Here, my y values are increasing by 2, and the x values are increasing by 1. Oh, look, once again, the y values are increasing by 2, and the x values are increasing by 1. So if you check out these ratios, you're going to see that there is a constant rate of change. Okay, this ratio is the unit rate. It's the numerical value for your unit rate. Even if we were to take a look at our initial value right here, our 1 is reflected in this equation here. Okay, so I want you to start seeing those connections. So now, moving on, we're going to scale our graphs. We're going to go by 1 since the x values only go up to 4. We are allowed to scale by 1. And the y values, since they only go up to 9, I'm going to also scale by 1 in the y's. So here, graphing our points on our graph, we're going to see that it is a positive line, because as we read this line from left to right, it's going up, so that's why I call it a positive. Now, what is our unit rate? Well, let's take a look. Our unit rate is going up 2 y's for each 1x. Again, it's going up 2 y's for each 1x, going up 2 y's for each 1x. It's going up 2y for every 1x. So I'm going to say that the unit rate is 2y for each x. And what is the initial value? There's 2 ways you can find that. You can take a look at your graph if you have an input of 0. Okay, so here you can say when x is 0, y is 1. Or you can take a look at the graph and see where that occurs. So here the initial value is at when x is 0, y is 1. So there's 2 ways in which you can look for it. You can look at it in the table if you have an input of 0, or you could take a look at a graph specifically looking for when x is 0. So in the past, we've only talked about 1 coordinate. So what happens if we talk about 4 quadrants? What's going to happen? Well, you're going to graph it just the same, except now you're going to extend your line through the entire graph. So why have I been stressing to you to make sure you extend your line through the graph? Because by doing this, you're able to find more solutions to your actual equation. For example, here is a solution, a nice intersection, a nice ordered pair. Here is another solution. Here's another solution. Here's another solution. Here's another solution. I didn't have to find those. Just by extending my line, I'm actually able to see them visually. So it is important that you understand that these lines go on forever. There's infinitely many solutions on this line because these lines never stop. So make sure as you draw your lines, you draw them neatly and you extend them through the entire graph. Okay, so now let's go ahead and move on to our very next problem. What I'm actually going to have you do is I'm going to actually have you pause the video and try this one on your own and see how well you do. Okay, so now we're back. So first things first, I'm going to go ahead and write my equation with a spot for the x so that I can plug in values for x. So for the very first one, since it does tell me that x is 0, I'm going to plug in 0 here. If x is 0, y equals 4. Next number, if x equals 1, if x equals 1, y would equal negative 3 plus 4, which is 1. Okay, so I'm going to go ahead and graph that 1, 1. Next one, what if x equals 2? Let's put that in. If x equals 2, y equals negative 3 times 2, which is negative 6 plus 4, which is negative 2. So we're going to go ahead and put negative 2 here, graph that. So it's 2 comma negative 2. So notice now with these 4 quadrants, some of your numbers are negative. So we're going to go lower into this quadrant here. So now continuing on, I'm going to go ahead and try the input of a 3. So plugging in a 3 here, y equals negative 3 times 3, which is negative 9, plus 4 would give me negative 5, so I'm going to put negative 5 here. I'm going to graph that. 3 comma negative 5 is right here. Last but not least, well, what if x equals 4? Let's plug that in. Y would be negative 3 times 4, which is negative 12, plus 4, which gives you negative 8. So plotting this point, I'm going to go over 4 down to -8, and I'm going to draw my line to extend it through completely. So again, by drawing this line, I can see that this is also a solution here, okay? And this would be a solution as well. So once again, extending your lines through the graph completely will reveal even more solutions to your equation here. So now, let's talk about our unit rate. What is our unit rate? Well, let's see. I'm just going to go ahead and pick a point here. Notice it's dropping 1, 2, 3 y's, whoops, 3 y's for every 1x. Let's check that again. It's dropping 1, 2, 3 y for 1x. It's dropping 1, 2, 3 y's for each 1x. It's dropping 1, 2, 3 y's for each 1x. So hopefully at this point you can see that the unit rate is -3y for each x. Our initial value, so once again what you can do is you can take a look at your table here. Since our input is 0, I can say this is my initial value. When x is 0, y is 4. So I'm going to go ahead and write that down. At x equals 0, y equals 4. But once more, what you could have also done is you could have taken a look here. When x is 0, so this is when x is 0, y is 4. So again, there's both ways. You can look at the table or you can look at the graph. So before we move on to the next problem, what I want you to see is this. That our unit rate of -3y for each x is found right here. Okay? That is our unit rate. As for our initial value, we can find that number right here. So I want you to start recognizing the patterns and seeing how these different pieces of our equation is being built into our actual equation. Okay, so let's just keep moving on. Now go ahead once more, pause the video and try this one on your own. Okay, so let's go ahead and check out to see whether or not you did it correctly. So first things first, what I'm going to do is go ahead and write my equation so that I am ready to plug in these different values in for x. So I'm going to go ahead and put y equals 5 times some number minus 7. So the very first value I'm going to input for x is going to be a 0. So let's try 0 here. If x is 0, what is y? Y is going to be 5 times 0, which is 0, minus 7, which would be -7. Now, what happens if x is 1? Let's put in a 1 here. If x is 1, y would be 5 times 1, which is 5, minus 7, which would be -2. And sorry, I forgot to mention, let's graph that point, 0, -7. Here, it would be 1, -2, which would go here. Now, the next value I'm going to input is, what if x equals 2? What is y? Well, y equals 5 times 2, which is 10, minus 7, which would give me 3. So let's plot that point. It would be 2, 3, so that point goes there. Next number, what if your input is a 3? So here, y equals 5 times 3, which is 15, minus 7, which would give me 8. So I'm going to put that here. Let's go ahead and plot that point over 3 up 8, which goes right here. And last but not least, let's plug in 4 for x. If 4 is x, y would be 5 times 4, which is 20, minus 3, which would give me 13. Here, you're going to notice 4, 13 falls off of our graph, so we're unable to graph that point. But we do have enough points now to go ahead and draw a line. Okay, so there we have it. But now let's take a look at our unit rate. Okay, what is our unit rate? What is happening every single time? Here, I'm just going to go ahead and pick a point. Let's start from here. It's going up 1. Let me change the color real quick. Here, it's going up 1, 2, 3, 4, 5. So it's going up 5y for each 1x. Let's keep checking. 1, 2, 3, 4, 5. So it's going up 5y for each 1x. Here it's going up 1, 2, 3, 4, 5y for each 1x. So at this point, I can say for sure that my unit rate is 5y for each x. Now, as for my initial value, again, there's technically two ways in which we can look for the answer. We can try to find it in our table, and it does show it here that when x is 0, so basically when your input is 0, that that y is -7. Or if you wanted to, okay, you could have also checked it here. When x is 0, y is -7. So here I'm going to say at x equals 0, y equals -7. So again, you can look at your graph. In some cases, you might be able to find it in your table. Okay. So you'll be able to find it in your table so long as you're using 0 as an input value. You'll be able to find out what your initial value is. So let's connect this back. Our unit rate of 5 can be found right here. That's the numerical value for our unit rate. What about our initial value? Our initial value can be found right here. So again, I want you to be recognizing these patterns and seeing where they're originating from. Okay, so now, moving on, go ahead once more, pause the video and try this one on your own. Okay, so now we're back. Hopefully after plugging the values in, you are able to get when x is 0, y is -3. When x is 1, y is -5. We're plotting as we go along. When x is 2, y is -7. So we're plotting these points. When x is 3, y is -9, which is here. When x is 4, y is -11, and that's going to fall off the graph, and that's totally fine. We have enough points here. We can draw in our line. Now, just one more time, just to really reiterate, by extending this line, you're able to find more solutions. Like, for example, this is a nice solution where you can see the order pairs. It's a nice intersection. Here's another example, another example, another example, another example, another example. In fact, even this one is a solution. The only reason why this is not going to be the best number is because you might not be able to tell what the numbers is exactly. By using these intersections, you know for a fact, for example, the solution is -3, 3. This point, you might not be 100% sure if the numbers that you choose for this coordinate is going to be very precise. So again, the whole purpose of extending our line is seeing the infinite amount of solutions. Okay, so any point on this sign is a solution to this equation here. Okay, so back to what we're talking about. Let's talk about our unit rate. Okay, so here we're going to see that it's going down 2y for each 1x. Again, it's going down 2y for each 1x. It's going down 2y for each 1x. So hopefully you're seeing the pattern. So my unit rate, I'm going to say it's -2y for each x. As for the initial value, I'm going to take a look to see if I can find it in my table. When my input is 0, which is right here. Okay. So here you can say when x equals 0, y equals -3, or you can see it in the table in our graph here. When x is 0, y equals -3. So I'm going to go ahead and say at x equals 0, y equals -3. But once more, let's go ahead and make those connections. Here, our unit rate is represented here in our equation. It's the numerical value. As for our initial value, this -3 can be found here in our equation. So hopefully you're starting to see the patterns a little bit better and seeing those connections. So we're just going to go ahead and keep moving on. Here, I'm going to actually show you this one. Notice our x values is no longer 0, 1, 2, 3, 4. In fact, it's 0, 3, 6, 9, 12. If you're wondering why, in a previous lesson we did talk about how in order to avoid working with fractions, what you would have to do is plug in multiples of the denominator. So since our denominator is 3, we chose multiples of 3 to ensure that we would end up with whole numbers. So here, this one's easy. If x equals 0, okay, it would be 2/3 times 0, which is 0 minus 1, which would give us y to be -1. Now here is a prime example of how this multiple of 3 will get rid of the fraction. So let me show you. So here I have y equals, let me change the color real quick, y equals 2/3 times a value for x minus 1. If we chose 3 to be x, I'm going to go ahead and put 3 over 1. You're going to see here that the 3's cancel each other out, leaving me with 2 over 1, which is 2 minus 1, which would give me a positive 1. I keep forgetting, I'm sorry. Make sure you plot the points as you go. So here is 0, -1 would go here. 3, 1 would be over 3 up 1, which would be there. Okay, so now let's try 6. I'm going to go ahead and replace 3 over 1 with 6 over 1. So here, because it's a multiple of 3, I'm 100% sure we can cross cancel. Dividing this by 3, this will become 1. This will become 2. 2 times 2 is 4 minus 1, which is 3. So if x equals 6, y equals 3. So you basically would continue this pattern. First, let me plot this point, 6, 3. It just goes there. You would continue plugging in values in for x to finish your table. Okay, here 12, 7 falls off our graph, so we won't be able to graph that. But we have enough points at this point, so you just go ahead and extend your line. And there you have it. So again, we are able to see some more solutions. Okay, for example, here is another solution. Here is another solution. Here is another solution. So you want to be very precise when you're drawing in these lines because it's able to reveal more solutions. Any point on this line is a solution. I cannot stress that enough. So now real quick, let's take a look at our unit rate. A friendly reminder, a unit rate is for each x. Okay, so in this case, what is happening for each x? Okay, so notice it's not a full, it's going from here to here, so it's not a full unit. Okay, it's less than that. In fact, to be precise, it's 2/3 of an x for each, 2/3 of a y. Okay, for each one x. So again, it's going up 2/3 y for each 1x. So my unit rate, I would write 2/3 y for each x. Okay, but let's talk about a rate in general. Okay, what's a more reasonable rate that we can see a little bit better? Well, I can see this rate between these points is going up 2 y's for every 1, 2, 3 x's. So notice this is not a unit rate because it's not over a 1x. Okay, so here this is a unit rate because it's 2/3 y for each 1x. This is a rate because it's over 3x. So here I'm going to say my rate is 2y for each 3x. And even if I were to continue, you can see it's 2y for every 3 x's. Okay. So now let's talk about our initial value. Our initial value, again, you can find it right here in your table when your input is 0. So here you can say when x equals 0, y equals -1, or at x equals 0, y equals -1. You could also find it in your graph right here. So at x equals 0, y equals -1. You can write that down. Now, I can't stress this enough. Hopefully you're starting to see it. This number here is a numerical value of your unit rate. Okay? Here is the value of your initial value. So see how this equation is being built on these two things, the unit rate and the initial value. Okay. So now moving on to the next one. Here, go ahead and pause the video and try this one by yourself. Okay, so now we're back. So hopefully you're starting to see again that we didn't choose 0, 1, 2, 3, 4 for a reason. Because we have this fraction and we want our numbers to be nice whole numbers, we went ahead and chose multiples of 4 to avoid those fractions. Is it wrong to use 1, 2, 3, 4? No, absolutely not. It's not wrong. But you're going to find yourself having to work with fractions. So you might want to rethink of whether or not you want to use 1, 2, and 3, 4. So here, once you plug in your values, I'm just going to show you once how we would do that. Here we would have y equals negative 3/4 times the value for x plus 5. The easiest one here, if we plug in a 0, we would have this number times 0, which is 0, plus 5, which is 0. Whoops, said that wrong. 3/4 times 0 is 0. 0 plus 5 is 5. So that's why we have 5 here. We're going to graph that point, 0, 5. Now here, I'm just going to show you one more example. What if x is 4? Well, I'm going to go ahead and put a 4 in here. Notice I'm going to put 4 over 1. Why? So that I can see that these 4's cancel each other out. Negative 3 times 1 is negative 3, plus 5 is positive 2. So I'm going to put positive 2 here. I'm going to plot that point, so over 4 up 2, and there you have it. So if you continue this pattern, if your input is 8, your output is negative 1. If your input is 12, your output is negative 4. If your input is 16, your output is negative 7. You'll notice by this part right here, 12 falls off of our graph, so we're not able to graph this. So it is 16. So this is going to have to be enough. I'm going to go ahead and draw my line. And again, by extending my line, I'm able to reveal more answers. I can see that this is a solution right here, and that's about it. Now, let's talk about our unit rate. How much is it moving for each 1x? Well, it's a little bit hard to see, but first of all, I want you to see that it's dropping about this much. You probably can't tell, but I will tell you it's dropping 3/4 of a y for each 1x. Okay, again, it's dropping down 3/4 of a y for each 1x. So here I'm going to go ahead and write that down. Negative 3/4 y for each x. And so to kind of show you, I got that number by looking at our equation. This is our numerical value of the unit rate. Now, what about a rate in general? Well, let's see. The visual for me I can see is, first of all, it's dropping down 1, 2, 3 y's for every 1, 2, 3, 4 x's. Continue on, it's dropping 1, 2, 3 y's. So since it's dropping, I should probably put a negative there. Correct that, please. It's going over 1, 2, whoops, let's fix that. It's going over 1, 2, 3, 4 y's. Sorry, 4 x's. So here my rate would be negative 3y for each 4x. Now initial values, here you can find it in your table. At x equals 0, y is 5. Or you can say, based off of this graph, at x equals 0, y equals 5. Both methods is going to give you the same answer. So I'm going to go ahead and write that down. X equals 0, y equals 5. Once more, let's make the connection that this is the unit rate. And this number here is the initial value. Okay. Moving on to number 7, it says find the equation that represents this linear relationship. So the first thing that I'm going to want you to do is find those nice ordered pairs. So identify them, go ahead and put points there so we can see where they are. Now from this, what you're going to do is find the rate. Okay, so here we're going to see that for every 1y, it's going over 2x. For 1y, it's going over 2x. For 1y, it's going over 2x. For 1y, it's going over 2x. So I'm going to go ahead and write that down. Now, in terms of unit rate, because we don't want it to be for each 2x, we want it to know for each 1x, we would translate that to 1/2 y for each x. Okay? So we basically made this into a fraction, 1 over 2. So half y for each x. Now, as for initial value, we need to see where is this graph starting at. When x is 0, okay, when x is 0, what is y? Y is 1. So I'm going to write that down. To x equals 0, y is 1. So by knowing these things, since I know the unit rate, since I know the initial value, which is the 1, I'm going to be able to build my equation as y equals 1/2 x plus 1. This number came from the unit rate, okay, without the y. And this value here came from the initial value, right here, okay? So notice how we're using the unit rate and how we're using the initial value to come up with an equation to represent this linear relationship. Okay, so now let's move on to the next one. So once more, what you're going to do is find those nice ordered pairs. Okay, identify those points. Now, we're going to go ahead and find a rate. Not the unit rate, just a rate. So here, I'm noticing it's dropping 1, 2, 3y. Since it's dropping, I'm going to go ahead and put negative. And then we're going 1, 2, 3, 4, 5y. Sorry, I keep saying this wrong. 5x. Once more, we're going to be dropping 1, 2, 3, dropping 3y, and it's moving over 1, 2, 3, 4, 5x. Once more, it's dropping 1, 2, 3y. Since it's dropping, it's negative, and it's going over 1, 2, 3, 4, 5x. So here, I'm going to say the rate is negative 3y for each 5x, but in terms of a unit rate, we don't want to know for each 5x, we just want to know for each x. So our unit rate would be negative 3/5 y for each x. Okay, so now all we're going to have to do is figure out what the unit rate, not unit rate, our initial value is. So that means when x equals 0, which is here, what is y? Y is negative 2. So I'm going to say at x equals 0, y equals negative 2. So now that I have the unit rate of negative 3/5 and negative 3/5 and our initial value with that negative 2, I'm able to build my equation. It's going to be y equals negative 3/5 x minus 2. So once again, this is your unit rate, this is your initial value. Okay, so now go ahead and pause the video for number 9 and try this one on your own and see how you do. Okay, so now we're back. Hopefully the first thing that you did was find those nice ordered pairs. And then you looked for a rate. So in this case, you can see that it's going up 1, 2, 3y. Since it's going up, it's positive. And it's going over 1, 2, 3, 4, 5, 6, 7x. Let's check again. It's going up 1, 2, 3y. For every 1, 2, 3, 4, 5, 6, 7x. Whoa, that's totally not 7x. 7x. So here my rate is going to be 3y for each 7x. But in terms of a unit rate, since I don't want to know for 7x, I just want to know for x by itself, we're going to have to divide both of them by 7, which would leave me with 3/7 y for each x. Now let's take a look at our initial value. So for our initial value, we need to check when x is 0, what is y? Well, when x is 0, y is also 0. So I'm going to say here, at x equals 0, y equals 0. So hopefully here, you're going to be able to recognize this is a proportional relationship. Why? Because it's linear, and not only that, but it also goes through the origin. It goes through 0, 0. So since it is a proportional relationship, it's going to follow that form y equals kx. So in this case, my equation is y equals 3/7 x. Again, this 3/7 is your numerical value for your unit rate, which can be found here. So technically you could put +0, but that's not necessary, and that's why it's not there. Okay, so now go ahead and also pause for number 10 and try this one on your own. Okay, so we're back. So first things first, find those nice ordered pairs that you can find on the graph. Oops, got ahead of myself. Here, if you're wondering why I'm jumping straight to unit rate versus finding a rate, it's because I can see how much it's moving for each 1x. So here I'm able to see that for every 1y, it's moving over 1x. For 1y, it's moving over 1x. So here, because it's per 1x, that is my unit rate. So I'm going to go ahead and say for each one, it's 1y for each x. My initial value would be, where is it at when x equals 0? Well, if x equals 0, y equals -7. So I'm going to write that down. At x equals 0, y equals -7. So my equation would be y equals x minus 7. So why? Because here, my unit rate of 1, there's technically a 1 in front of that x, is represented there. And my initial value is represented here. So it's the same idea. Keep that in mind. So that concludes our lesson for today. Thank you so much for tuning in. Hopefully by the end of this lesson, you feel comfortable graphing linear equations. And until next time, thank you. Bye.